What is your name and what do you do?
My name is Poulidis, and I am the VP and General Manager of Mobile and Internet of Things at Marvell Semiconductor.
Now describe your customer and the vertical markets that they're in.
Sure, our customer base is very diverse. We've got customers spanning from consumer electronics vendors to smartphone manufacturers, to storage solution vendors, networking equipment vendors, in many different areas of technology, many different industries.
And what are some of the bigger verticals that you find your product being sold into?
Sure, we have a big presence in mobile,
okay.
Where we're providing our LTE solutions into mobile phones and other mobile devices. We also have solutions that are going into storage applications and networking equipment.
Yeah.
And the verticals that they go into, really, it's everything.
Yeah, it's everything.
You know, from big industry to consumer electronics. You'll find things in your home that have Marvell chips inside of them, to automotive, wireless connectivity in cars.
Okay.
We provide a lot of solutions for that as well.
Now, you mentioned mobile, is there an IoT angle on the mobile side for your chips?
There sure is. Mobile is really just another means of connecting. And so in some applications where there isn't a close proximity to a wireless Wi-Fi network, for example, or where Bluetooth may not be suited, because that's really a near proximity type RF technology, it might be better suited for something like LTE or 3G, especially for industrial type applications or perhaps even farming. Agriculture, you know, sensors out in the field.
Right, right.
Yeah.
Well, actually, let's talk about networking a little bit.
Sure.
So, what protocols do you support? I mean, we're talking about connectivity. How do the chips work from a connectivity point of view?
Sure. We provide the underlying solutions. So at the MAC-PHY, baseband level, we provide solutions that span from Wi-Fi, wireless connectivity to Bluetooth to Zigbee and LTE. 3G. Really, the protocols above that could be anything. You know? So TCP/IP, and then anything above that is we're really agnostic to it. What we really provide is the underlying technology for connectivity and also computing.
And are you finding any trends? I mean, in terms of the protocols being used?
Sure, we're seeing different industries and different applications are gravitating towards certain types of RF technology. For example, in wearable applications, we're seeing a lot of Bluetooth and Wi-Fi.
Okay.
In some cases, LTE, if the connection has to be on all the time when you're out and about, then 3G or LTE makes sense. But in applications where you really just need that close proximity or that connection to your smartphone, then maybe Bluetooth is all you need. In home applications, home networking applications, for example, smart thermostats or maybe sensors within the home, you could use everything from Bluetooth to Wi-Fi to Zigbee if you need a mesh network, for instance.
At the same time?
Provides. Yes, exactly. We've seen things being used at the same time. Of course, Zigbee would need to be bridged to your home network through a Wi-Fi Zigbee bridge.
Of course, yeah.
But Zigbee does provide a lot of benefits that Wi-Fi doesn't provide today. For example, mesh networking, a very robust and large mesh network. On the other hand, Bluetooth has benefits that it provides and lends itself better perhaps to wearable type applications.
So Marvell, you sell a chip. Is it a system on a chip for IoT or what's the direction? What are maybe the different form factors, or I'm not sure how you kind of describe the different products.
Sure, no, that's a great question. I mean, we could, there are solutions out there that just focus on radio technology or a microcontroller, for instance, just for the computing capability in embedded systems. We provide the full spectrum. So we have a full SoC for IoT that includes microcontroller and RF together in a single chip, together with power management and memory. And so from a system or a hardware developer standpoint, you really don't need more than just our chip and perhaps a few discretes externally. But everything is pretty much self-contained. From the, like I mentioned, the microcontroller to the RF, whether it's Wi-Fi, Bluetooth, or Zigbee, we have a solution for each one of those. that includes the microcontroller, the memory, and the power management.
A microcontroller, what type of microcontrollers?
We have different kinds depending on the application. There are Cortex M3 or M4, depending on what's needed for the different type of application, how much computing resource is actually needed, how many, what kind of computing cycles you're actually going to perform in the embedded system. And we find that different applications have a need for different computing resources.
So someone's designing a new product, and they're taking a look at the different, I guess, chipsets that are available. What's your advice, not necessarily specific to your own company, but what's your advice to be considering when making that decision, the purchase decision on what chips to use?
Sure, there are a few fundamental things that you need to look at if you're a developer or manufacturer, is power consumption, the level of integration, because at the end of the day, it's not really it's a chip decision, it's really a bill of materials decision. Right. It's a platform decision. Right. When you're looking at building out an entire platform, you need to look at all of the components on the board. And if a silicon vendor such as Marvell is offering a solution that has deep integration, then you don't need as many external discrete components in your system. So you can design it to be more power efficient, take up less real estate, so you can create much smaller devices. Okay. And so integration, power management, and then performance is, of course, the other very important one. Yeah. Is if you compromise performance in order to improve power, it really defeats the purpose. Because at the end of the day, Internet of Things wouldn't be the Internet of Things if it didn't have connectivity. Yeah. And so you need that performance and connectivity.
Now, what about from a developer's point of view? What are the tools that are used to program the chip?
Sure, that's an excellent question. We've spent a lot of time putting effort into creating a very robust software development environment. We have a couple of programs that we're undertaking within the company. One of them is geared more towards the maker community, where they can very quickly, very easily prototype a solution. And we have something there, it's called Kinoma Create. And it's a platform that includes hardware development platform in addition to software tools and it's based on, it's an embedded Java virtual machine, a based solution, where all you need is JavaScript knowledge. And so basically a web developer can build a product based on that Kinoma Create platform. And so that's a very, very simple way to prototype something. Right. Now, when you need to graduate from that to an embedded system that is made for high volume manufacturing, then you'd move into what we call the Easy Connect platform. And that provides a very robust set of tools for enabling developers to create something on a platform that can then go directly into volume manufacturing.
Okay, so and are there any standard development platforms, or is it every manufacturer kind of offers their own development platform?
Every manufacturer would have to have their own development platform to work specifically with their chips, and to be able to tune the different components and turn the different knobs within their chip to optimize power, to optimize performance. And so that part of it does need to be proprietary. Yeah. But on top of that, everyone should be embracing open standards, and we do. We make sure that we embrace the openness of different standards out there for connectivity, for device communication, device interaction, to ensure that a developer coming from another environment could easily adopt or adapt their solution into our platform and then take that solution into the marketplace fairly quickly.
It sounds like that would be a pretty important component, the development aspect of the chip.
It really is. It really is. I think, especially in the IoT world, where you have such a diverse group of developers in that community, ranging from very different industries, we can't have a solution that fits everyone. And at the same time, you can't customize solutions for everyone. So what you need to do is build a very robust, open framework so that developers coming in from all these different industries can quickly and easily develop on a platform that's very open.
Let's shift gears now a little bit on the business side of things. What are the costs involved for purchasing chips? I mean, you don't necessarily have to give exact numbers, but what's the cost structure? What's the business model, so to speak?
Sure. So, if you're developing a connected product, for example, that provides utility to a consumer, and let's just use an example here, it could be smart lighting or smart thermostat or a smart door lock, You of course have to look at the embedded system itself and look at all the components needed in order to make that device smart. And so, as I mentioned before, you'll need to look at the silicon level, the computing and connectivity that you'd need to put into that device. And so there is a cost element to that. Then there's the cost of developing the application and then managing the application for whether it be the smartphone or some other, perhaps even a proprietary panel or some kind of device that controls that internet connected item. Then you need to look at cloud services, because there might be a remote access element to that service. If you want somebody to be able to control their smart home remotely and through a cloud, you'll need to provide cloud services. And so as a developer or a creator of a technology or a solution, you need to look at it from every level, embedded, application, and then cloud, and then ongoing management. And there's one piece in there that cannot be overlooked, which is security. A lot of time has to be spent on building out a robust solution that you offer a consumer to give them comfort that you've built it from the ground up with security in mind, and the ability to provide and protect their data when they're entrusting you with that data.
Yeah, and from a chip point of view, what's the security? What should you be looking for from a security point of view?
Yeah, so we've taken many measures to make our solution very secure at the embedded level. Our partner, ARM, for example, has secure elements within the core. We build up on top of that, and we make sure that everything from the chip level all the way up to the point where we hand off to a system that's outside of our chip, that all of that is secure. We build upon secure framework, both in software and hardware.
So security protocols, you're using IPsec?
Encryption, that is well known out there. Banking grade security encryption, and doing it at the chip level all the way through. Having secure cores within our chip that ensure that they can't be hacked. And I mean, I hesitate because everything can eventually be hacked, but at least taking all measures to make sure that we put whatever we can in there to ensure that we have the utmost security from the ground up. Yeah.
Now, what type of advice can you give our viewers who are planning an IoT deployment or maybe upgrading from M2M?
Sure. M2M I see as being really a subset of IoT. It provides that machine-to-machine communication, but then you need that internet connectivity element. You need that intelligence in the cloud to do the analytics, to do the crunching of all that raw data that's being collected from the field. There's going to be an evolution here of M2M has been around for a very long time, and what we're going to start seeing now is how that is going to tie into other systems that are being connected, and tie into other cloud services that are going to be doing the analytics for that data. I call this not really the Internet of Things, but I call it the relative existence of things, where you have things relating to each other and feeding off of each other, and that creates a compound effect where it just compounds the growth, and the network it adds a network element to it, where you no longer have isolated systems providing a single utility, but you have contextual interaction between devices, offering just so much more value to both consumers and even industry applications.
So when someone's choosing their chipsets, what should they be thinking about? I think you went through the 4 of the main points, but is there anything else they should be considering from an advice point of view?
Really just look at whether it's from an embedded system level or all the way up to the cloud. Look at using open standards as much as possible, because that's what's going to enable both you and also your community out there, whether it's a community of developers or a community of customers, to leverage what they've already done. Everyone likes to talk about openness, but not everyone is open. And so we embrace that, and we try to use as much as possible open protocols and industry protocols that are well accepted out there, both for networking, for security, for whatever else we're implementing.
Okay. And I would think the most important of all would be IP. I mean, from an open standard point of view, specifically communications.
Exactly, communications, because at the end of the day, without that, then you can't have what I called the relative existence of things.
Relativity.
Can't talk to each other. Yeah.
All right, so how can people find out more about your products and your company?
Sure, I mean, the easiest way is our website, marvell.com, and reach out to us. We are here to help the developer community, the device manufacturers, or anyone really looking to bring the Internet of Things into reality, and we're helping companies from across different types of industries and building different types of applications.
Great, thank you very much.
Thank you.